Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed about various types of the system and how we can define the order of the system and how we can uh, classify or represent the system. We have seen the very important concepts. So in this video, we are going to learn about the first order system. So what is a first order system? We already learned about the order of the system, in which it states that the highest power in the denominator polynomial of s. So we are kind of this is kind of straightforward thing, uh, that if we say that it is a first order system, then the number of poles for this system can be equal to 1. So and in the denominator polynomial in the transfer function equation can be written in as a linear equation in one variable s. So let us start our session with the first order system, how we can define that. So the denominator, which is called the characteristic equation of the transfer function, if it is the linear equation and is having the highest power of s as 1, then we can say that as a first order system. So this is a sample kind of first order system with a time constant tau over here. So let us actually find out how we can arrive at this kind of transfer function over here. So considering a unity negative feedback system. So we have considered a closed loop system with h of s is equal to 1. That is what we call as unity feedback, and we are giving a negative feedback to this corresponding input in order to kind of eliminate the changes or disturbances in our outputs. So let us so this is the diagram what we are discussing about. So we are giving a negative feedback with the unity gain, that is no gain is multiplied over this signal, and this same signal which is being subtracted with this input to kind of result to kind of settle the changes in output or disturbances. So if we solve this circuit diagram over here, we can say we can have the feedback negative feedback system having the transfer function g over 1 plus gh. So if we substitute h of s equal to 1, because there is no block over here, the gain of this path is 1. So we can say that the overall transfer function of this block diagram can be written as gs over 1 plus gs. So if we substitute this gs over here, this is what we have, and this is what we call it as a first order system. So let us move on to, so this is the output, corresponding output in Laplace domain with respect to input R of S. So let us have different signals R of S and how it will lead to the corresponding output. So if we apply an impulse signal to this first order system, we already know that an impulse is a signal with the Laplace transform as 1. So we can have so an impulse signal is nothing but a signal with having a one area under it, and we already discussed that if we apply Laplace transform, then we can get 1. So if we substitute this in output equation, so if we substitute rs equal to 1, so what we have is the cs. So if we apply inverse Laplace transform to this, then we can get this exponentially decaying term, which is being uh, considered as a time domain output. So this is the graph which shows the corresponding input output relation. So what we have given is to the system, it is we have given an impulse signal which is situated at t equal to 0. And if we gave it to the first order system with time constant capital T over here, then what we have is kind of exponentially decaying signal. So here the input, it is not ideal in the case, in the sense, this impulse having some finite width over here. So if we apply this input, this impulse, then we can have some similar kind of output which is being depicted over here in this kind of graph. So, and this response is dependent on this time constant. So the slope of this time constant is so this value is 1 by tau. And if we have a time constant, based on the time constant how fast it is decaying or how slow it is decaying, we can kind of assume all those things. So thank you guys. In the next video, this is all for today's lecture. In the next video, we are going to apply uh, a unit step signal to this first order system which we have discussed. So if we apply unit step signal to this first order system, how it will react and how what will be the output, we are going to discuss. So thank you guys.